So hi and welcome back to Roy's Desk. I know it's been long since I uploaded the last video. I'm really sorry for that, but I went to my hometown and I could not record any videos in there. So I'm again back with this topic. But yeah, I cannot promise a consistent video uploading schedule because now my hybrid work from home days are over, it seems. I have to go to office 4 days a week now, and it's really hard in that case to make videos and edit and upload in a frequent manner. But still, I'll try my best to upload videos as frequently as possible. Coming back to the topic, as you have seen from the title, this video is about this 3-way tone control board that I was working on. So we will talk about this board, we will test it definitely. So without wasting any further more time, let us quickly get started. So this is how the PCB looks like. I got this from Lion Circuits obviously, and this is how the board looks like. I've used all the non-polar capacitors from DIY audio card. I will give the link in the description obviously, and the op-amps are NE5532 from Ultimax Audio. So one thing to point out is this is a mono board, so each side, or say the left channel, uses 6 op-amps and the right channel also uses 6 op-amps. So total in 12 op-amps for a stereo, because each stage like the bass, mid and treble all are 12 dB per octave. So that's why we need around 6 op-amps per channel. That's like a mono amplifier here, another mono amplifier here. So we just need to stack it together to make a stereo. I could have made a single board consisting of both the sides, like total of 6 op-amp ICs, but instead I have made 2 separate boards. The reason is because, see, in Lion Circuits the minimum order that you can place is 5 boards like this, and if I would have made a single board, I needed to have around 5 of this, which would have just become useless because I needed only 1 stereo board, or maybe later 2. But in this way, if I have 2 separate boards, then if I order 5 PCBs, then I have, this is 1 stereo, this is another stereo, and there is another set of stereo. So like 3 stereo boards I would have. So that's like saving the cost in there. Or else when I will show the PCB, you can just stack 2 of this together and make a single PCB also. No issues in that. I'll show you the circuit and PCB later. But now let us test this one with our oscilloscope. See the response. Later we'll do the sound test. So I'll be powering this module with the homemade dual rail power supply. I've set it to 12 volts. And I'll be feeding the input to this through this again homemade gain preamplifier, and I directly connected the output to our oscilloscope. So I'm feeding a 1 kHz sine wave in here. As you can see, the output is pretty clear in here, but that's not my goal to show you. So I don't know if you can see you can see. So the frequency is 1 kHz and the peak to peak voltage is 4 volts, 4.2 volts. Let me see if we can increase it to maximum. Okay, this is the maximum voltage, peak to peak output voltage. Now, what I want to show you is, see, 1 kHz is mid frequency or the band pass range. So, ideally, with this 3-way tone control board, only the mid frequency will be affected with the mid frequency pot. Other than that, the bass pot and the treble pot both should not affect the amplitude or of the wave. Well, ideally it's supposed to not affect the amplitude, but it will affect a little bit because obviously this is not a digital signal that will just shoot up and will just go down directly, because there will be a slope of rise and slope of fall, if you know what I'm trying to say. So let's tweak the bass pot. So as you can see, this is the bass pot. See, the voltage or the amplitude is not changing much. So the maximum is obviously 4.1 and the minimum is 3.6. Let it put it to maximum. Again, if I change, so this is the treble pot. If I change the treble pot, it's again 3.36 and 4.16. But see, this is the mid pot. Now if I change this, you see, you can actually vary it quite nicely. You can increase the amplitude to maximum 7.5 volts and you can reduce it down also. So the mid frequency will be only affected with the mid pot in here. Let's try same for the bass frequency and also the high frequency. Okay, so that's our bass frequency in here, and as you can see, it's really a good boost in here. I did not increase or decrease the input voltage. This is the treble pot and I'm changing it. Nothing is happening. Nothing much is happening, I would say. And this is the mid pot right in here. If I change it, only a little bit changes. Not much difference. It's still 13 volts. Only the decimal points are changing. But if I change the base pot now, as you can see, it actually affects this. So now let us check for the treble frequency also. So that is my treble frequency in here, 10 kilohertz. And if I now change the base pot, this is the base pot by the way, nothing happens. Change the mid pot in here. Nothing really happens. Now if I change the treble pot, as you can see, we can vary the amplitude with the treble pot only. So this proves that each section is individually working and filtering out the respective frequencies. We will go to the sound testing now. So let me walk you through the connections while I am doing it. So first comes our linear power supply, dual rail. Then our 3-way tone control board. And this is where the 12012 power comes in. Let me connect it to the negative supply in here. Blue is the negative, black is common, and red is positive. Now comes the input to the tone control board. I'm using this RCA connector in here. This is what I'm going to use for giving the input to the tone control board. Now in case if you want to know what is this is a gain preamplifier with this Bluetooth module, and you can check out this video in here where I have built this from the scratch. There are two parts basically, you can go ahead and check it out. So output of this module is going to go into the RCA jack in here. Now comes the amplifier power section where I'm going to use this toroidal transformer, from where I'll be taking this 13013 winding, going to our rectifier circuit in here, and this is our amp that is going to be used. And this is a LM1875 amplifier, so I'm going to use only one of the section in here, and the output of the tone control board is going to come to the input of the amp like so, and obviously the power is going to come through the output of this rectifier board. So all the connections are done now, and the output of the amp is going to be connected to our woofer. That's it. If you look at the board, it's sitting like this, and in such a way, the last one is the bass, then mid, then treble, and the master volume. So I'll be turning each pot one by one, and I will show you the different effect that it is having on the sound. So let me play some YouTube safe music now. Okay, the bass is very good. I'll just reduce the bass now. This is the bass pot. So okay, let's try only bass now. As you can see, the bass is really good. Now let's turn only the vocals up or the mid up. Now let me keep only the treble. I'll reduce the mid also. Okay, as you can see, it's really noise free. I mean, at least no audible noises are there in this, and you have seen that each section of the tone control, it's a three-way, so mid, bass and treble, all three sections work individually and in a proper way, and that is what you should always try while designing one three-way tone control board, that all the different stages should work irrespective of the other one. It should not be dependent on the other one. Let me play some only bass music song and you will see. So the sound testing is done, the frequency testing is done, only thing remaining is to check out the circuit of it. Well, I'll tell before only that this circuit is not designed exactly by me. I found it somewhere in some website, I forgot the link, but definitely if I get the link I will put it in the description. Well, there is nothing much to understand in the circuit. There are three sections of filtering happening. First section is the low pass filter or the bass section, which is having two stages of filtering, hence 12 dB per octave. Next up is our mid section or the band pass section, which is having mixture of low pass and high pass, again two stages, hence 12 dB per octave. And the last section is our high pass filtering section, which is also the treble section, again 12 dB per octave. They all are fed into the output op-amp, which is having some gain into it, and then I have added another filtering stage for RF and interferences, and that's it done for our circuit. The values of the RC filtering is where you have to be a bit precise, and you have to calculate the values such that the conjunction of all the signals doesn't interfere with each other. There will be particular places where the cutoff will happen, so you can play around with the values, but these are the values which I have used, and that's the circuit in easy EDA. And then going forward, I have designed the PCB of this, and I have ordered the PCBs from Lion Circuits. So I stacked one module on top of the other. Together it makes a stereo system. These are the ports right in here. I actually need a smaller hex nut, like a 30mm. This is a 50mm hex nut, so I don't need this big. And this is similar to our high pass section, as you can see. So both the filtering sections are done, the tone control and the high pass. And again, if you are new to my video, if you don't know what I am doing with my amplifier setup, please go check out my previous videos. You will get the idea why I need a separate high pass filter section and also the tone control board. So it's time to end the video. Well, in the next video, I don't know when it will come. I will try to make it as soon as possible. But next video, I will directly come with the finished amplifier project, with the finished amplifier cabinet. Basically, I'll put this one and everything that I have shown you before in my other videos inside the cabinet, and we will directly see the testing of that amplifier. Well, better not to drag the video. I would say that that's the end of the video in here. I will see you in the next video again. Please like, share and subscribe to my channel, and don't miss to press the bell icon. You will get notified whenever I upload a new video. I will see you soon. Till then, bye bye.